All right, hey y'all. Today's objective is simplifying radicals. A radical is the square root symbol, and there are, well, two methods that I'm going to show you today. There might be more, but I'm going to show you one that's called upside down division, and the other one is called a factor tree. Hey, I just called you.
Oh, so we should.
Sorry. Do you need me?
Start your video over again.
No, I'm going to keep going. All right, so do you need me to?
No.
Okay. So the square root of 36 is positive or negative 6, and this is a perfect square, so it comes out evenly. The square root of 40 is not a perfect square. Therefore, if you type this in your calculator, you would get some decimal approximations. So the whole purpose of simplifying is to come out with an exact answer. So for the square root of 40, it would be 2 root 10, and I'm going to show you how I got that in a moment. But that is an exact answer. So the whole purpose is simplifying it down to an exact answer, no decimals. Okay, so here are some examples. The square root of 50. The first one, a factor tree. So if you're going to choose the factor tree method, you have to use prime factors. So I broke it down to 2 and 25, and then 25 to 5 and 5. Now, if you have a square root, the only way to come out of the radical is to have 2 squared, 2. So you circle your pairs. We have 2 5s. So a 5 can come out of the radical, and whatever's left stays inside the radical. So a 5 comes out, and a 2 stays in. So this would be 5 root 2 is your answer. Upside down division is the same thing, just looks different. You start with 50. You draw a line, and you divide it by the smallest prime number, 2. 50 divided by 2 is 25. We need to divide it by the smallest prime number. So 25 divided by 5 is 5. 5 divided by 5 is 1, and then we stop. You have to circle your pairs. So a 5 will come out of the radical, and whatever you have left stays inside the radical. So same thing, just 2 different methods. Square root of 72, factor tree right here. We're going to factor out, or use prime factors. So we divide 2, 36, and then 2 and 18, 2 and 9, 3 and 3. Factor tree, remember you have to use your prime factors. Upside down division, you're going to divide by the prime numbers. 72 divided by 2 is 36. 36 divided by 2 is 18. 18 divided by 2 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. You stop at 1. We need pairs, so I have a pair of 3s and I have a pair of 2s. A pair of 2s and I have a pair of 3s. The pairs can come out of the radical. So we're going to multiply. 2 times 3, we get 6. And then whatever I have left, I have a 2 left in both problems, that stays under the radical. So my answer is 6 root 2. All right, so number 3, I have 7 times the square root of 27. I'm going to show you both ways. 27 as a factor tree, 3 and 9, 3 and 3. 27 an upside down division. 2 doesn't go into it, so I'm going to divide by 3, and that's 9, 3, and then 1. I'm going to circle my pairs, so I have a pair of 3s in both. So a 3 is going to come out of the radical, and whatever's left stays in. So square root of 27 is equivalent to 3 times the square root of 3. But this 7 that I have here, I need to multiply it by this 3. So my final answer would be 7 times 3, 21, and then root 3. So that is the exact answer. The 7 on the outside just stays there until you get another number on the outside, and then you're going to multiply those together. And because the 3 doesn't have a pair, it stays under the radical. Okay, so more examples. 9 times the root of 18. 18 is not a perfect square, so you can use upside down division or a factor tree. I'm just going to show you upside down division. Divided by 2, divided by 3. So I have a pair of 3s that can come out, and a 2 left under the radical. If you did a factor tree, you should hopefully get the same thing. So my 9 on the outside is going to multiply by my 3 on the outside. 9 times 3 is 27, and then root 2. So that will be your answer. Example number 5. Square root of 25. Well, the square root of 25 is a perfect square, which is 5. And then 4 times 5 is 20. So right now, notice we're only using the principal square roots, the positive square roots in this example, in simplifying radicals. You're just going to assume that you're going to use the positive roots. Okay, so 3 times the square root of 29. 29, when you try to factor it, it's prime. So that means this is simplified. Alright, it doesn't simplify anymore because 29 is a prime number. 3 times root 99. So 99 can go 3, and then 11. I have a pair of 3's. So when I simplify the square root of 99, it's going to be 3 root 11. Multiply that by that 3 up here, so we're going to multiply the 3's together. So my answer is going to be 9 root 11. So number 8, 45. I'm going to divide it by 3. I'm going to divide 15 by 3. 5. We have a pair of 3's. So 3 root 5. I need to multiply my 3 and my 2 together, so my final answer is 6 root 5. Alright, so you try number 9. Try this one on your own. Press pause, and then press play when you're ready to see the answer. 2 would be 26. So 2 root 13. You multiply 4 and 2 together, so you have 8 root 13. Okay, so now we have to go into examples with variables. I've shown you how to do it just with numerals. So now when we have variables in it, you're going to do the same thing. If you have a square root, that means you have to have pairs in order to come out of the radical, to simplify. So the square root of 16 is 4, so I know that a 4 can come out. And I have 2 x's right here. So that means the square root of x squared is just x. If you have 2 x's and you have a square root, they can come out, so the answer would just be 4x. Essentially, I found the square root of 16 and the square root of x squared. Number 11, square root of 8x. So first let's look at the 8. 8 is not a perfect square, but I know if you do a factor tree, I have a pair of 2's that can come out. So it's going to be 2 root 2. Now let's look at the x. How many x's do I have? I only have 1. So if you only have 1 x, it can't come out of the radical because you have to have at least 2, so the x would stay inside the radical. Number 12. 15. Square root of 15 is just broken down to 3 and 5. I don't have any pairs that can come out of 15. But I have 3 x's. So I can take a pair out, and then 1 will stay inside the radical. So maybe that helps you. Since you have 3 x's, you have to have a pair to take it out. And so once you take your pair out, you have 1 left that stays under the radical. Number 13 is a cubed root. So that means instead of pairs, we need 3's. So 80, 2, I'm just going to show you upside down division. So I need triples. So I have 1 set of triples. So that means I can have a 2 come out, and then 2 times 5 is 10, so I still have a 10 inside. The n5, that means you have 5 n's. 1, 2, 3, 4, 5. If I have 1 set of 3, they can come out, and then I have 2 left, so that stays on the inside. I know it can be confusing. Number 14, the square root. So if it's the square root, I'm looking for pairs. Square root of 64 is 8. That is a perfect square. If I have 3 x's, then I can take a pair out, but one little x has to stay under the radical all by him or herself. And number 15, the fourth root of 81. There's no variables, so we could do upside down division, or you could do a factor tree. But we want to find the fourth root of 81, which is going to be, let's start with 3. So 27, 9. And when I circle my groups of 4, I have one group of 4, so this is going to be a whole number, an integer answer, and the answer is 3. Okay, so one last one. I want you to work this one on your own, 192. You can either do upside down division, or you can do a factor tree. So that's going to be, something 91 maybe. Then you have 5 x's, 7 y's, and 2 z's. And remember, we're looking for the cube root. So we need to pull out triples. Oops, you try. I want you to try this one on your own. We will go over it in class. I know this can be confusing, but we will work on it.